Just like normal, we'll give it a title. Today we are going to be learning the product rule. We are in day 5 already, and we're even taking every other day. Today's day 5, right? I think. Maybe it's only day 4. AASL 2, we're going to be going over 5.6. And this is called the product rule. Product rule. And of course, what this product rule is, or what does product mean in math? It means to multiply. So we're going to be looking at what do you do, how do you handle things when we're multiplied together. So let's start off by looking at this question. F of x equals x plus 3 times 2x plus 1. Now this question doesn't really intimidate us all that much. It does not look like a polynomial. It does not look like we can take those exponents and handle them. We have, a binomial and a binomial here. If the question was only this, we could probably only this, we could probably handle it, or if it was only that, we could probably handle it, but it's both of these things together. Power rule right now is not really working, but we saw this when we did power rule.
Sorry to interrupt, but I was supposed to get called out at 9:45, and they usually have problems with me getting called out. So.
What do you want me to do?
Can I go down to attendance and ask them?
Are you going to check yourself out, or are you going to get picked up?
I'm supposed to check myself out.
Okay, sure. Why don't you... Yeah, just go ahead down there. I guess I'll take my pass because then you'd have to come back anyway. So just go down there and ask about it. No big deal. When we go to do this, power rule is not really working. So we're going to need to maybe do a little bit of rewrite. This is something that we did see happen. Still staying in f of x, not taking a derivative. We can do a FOIL. Have a great weekend if I don't see you again. 2x squared plus x plus 6x plus 3, and then we can combine those together and you're going to get 7x. Let's just do it all here. Plus 7x, and now we could certainly take the derivative. F prime of x is equal to, actually take the derivative here. Put the 2 out front, 4x, and then that's going to be 7. So this derivative is not all that difficult, but this is also 2 very simple things multiplied where we are allowed to just do a quick FOIL, right? If all of a sudden we start putting some crazy stuff in here, we start putting some fractions, some exponents, some sines and cosines, and all of a sudden this can be a little crazy. So let's use this example to learn about the product rule. And just to be super clear, this is not the product rule. This is still just the power rule. The product rule is a new one we haven't seen yet. Pick a color, come on. The product rule. If I do like a straight on right, it comes out white, but it does like a scratchy. If I do it at an angle, it's not super scratchy, but sometimes if I do it too much of an angle, it comes out green. I don't really know. All right, product rule. If f of x is equal to g of x times h of x. And again, I hope we're kind of building up our tolerance for these, kind of more experimental, which is not really the right word, but more lettery examples. This just means f of x is one thing multiplied by another thing. Then f prime of x is going to be equal to g prime of x times h of x Okay, so we just want to take the derivative of only the first one, that can't be right, plus g of x h prime of x. And we have a whole lot of parentheses and a whole lot of x's on here, but bearing with me, we have first and second. And all we need to do for the derivative is take the derivative of the first and keep the second on there. Don't take the derivative. Plus, leave the first one alone and take the derivative of the second. So you're going to end up with two pieces, and each of those pieces has one of the derivatives and one of the originals, the other derivative and the other original. That's it. So let's see f of x, which we had up here, if we can solve this question using our new product rule and get 4x plus 7. So, our f of x, again, we already solved this question. F of x equals x plus 3, 2x plus 1. And without foiling, let's use our new product rule to find f prime of x. Now, this is a addition sign, and addition is commutative, so it really doesn't matter if you want to start with the derivative of g and the plane h, or you could do it the other way first, and you could leave it as the original g, take the derivative of h first. It doesn't matter the order of these two things, because you have a plus in the middle. But you do need to do one of them. I just like to go ahead and rip into the derivative of the first thing. So what is the derivative of this first piece? Yes, that's the first half, but the derivative here is going to be 1. And then keep the attached piece of 2x plus 1. That's the derivative of f, or I should say, this is like g prime and regular old h. We're going to add that to regular old g, and then we're going to go with h prime, which is 2. Are we following along where stuff's coming from? Derivative, original, original, derivative. And now we have a little bit of a mess to sort out, but we have some nice, easy, small stuff. That's going to be 2x plus 1, and that's going to distribute the 2. 2x plus 6. That looks like 4x plus 7. The exact same thing that we found when we did it the other way. So, the product rule is legit, of course. The product rule works. This was a very easy question. Let's see still an easy example that we desperately need this for. So let's go with g of x equals e power x sine x. This doesn't look anything like a polynomial. This doesn't look anything like power rule. We are just completely busted here. But if we think about them individually, e to the x, we already know that. That's an easy derivative. Sine of x, we already know that. That's an easy derivative. So separately, we can handle this. So we're just going to do our little pattern. G prime of x is equal to, let's go with the derivative of the first. And that's nice because e to the x is our favorite derivative. E to the x. And then let's keep our second one original. Sine x. Then, plus, on the second piece, let's keep our original. Weirdly, it's still e to the x. And now, let's take our derivative of the second. Cosine x. And so there you go. There is our derivative of g. Gonna go with a little bit of a pattern. How are we feeling about this? Doing okay? Doing all right? Awesome. At this point, there's really not much more to go through. You're just going to need to follow this pattern, and product rule is what we're learning today. Let's, we're gonna do one question, and we're gonna do it two ways. So we're gonna have, I hate that it does the green sometimes. Each of x is equal to x squared minus 2, 7x cubed plus 5. Let's do this two ways. When you get your quiz or when you get your test, and it's your job to take the derivative of this, if it just says take the derivative, you can go for either direction. You can either do your algebra, then derivative, or you can get straight into your more complicated derivative and then do your algebra. You might have a preference. Now, the question might say mandatory product rule, and then of course you do mandatory. But let's do it both ways here. Let's do it the old algebra way. First, derivative, that would be 7, or not derivative, FOIL. Goodness, get it together. That's going to be plus 5x squared. That's going to be minus 14x cubed. That's going to be minus 10. Now our derivative is looking pretty easy. 35x power 4 plus, I guess I'll do this one next. So we'll do minus 42x squared plus 10x. And that 10 is going to go away because it's just a constant. And there we go. That's my derivative. Let's do this same question, and let's do it with the product rule. We've got same thing. H of x is equal to x squared minus 2, 7x cubed plus 5. Product rule. H prime of x is going to be the derivative here. That's just 2x times the original. Then we're going to keep the original and do the derivative. Now we need to make it a little bit nicer. That would be 14x power 4 plus 10x. Plus over here, that's going to be 21x power 4 minus 42x squared. Is that right? Yes. We're going to end up with two of these that are x power 4, so those can combine together. That's going to make 35x power 4. We've got that minus 42x squared plus 10x. Are those the same things? Nice. You kind of get to develop your own sense for which one's easier, which one's faster. Sometimes you might start one way and think, wait a second, this is awful, I might have to go the other way. These questions we've been choosing are pretty friendly for eventually you can go for the algebra way first. The homework is going to kind of start out that way, and then pretty quick you might be thinking, yeah, I do not like doing it the other way. The last thing we're going to talk about is derivative notation. Okay, this is one of those things that sneaky, if you don't really pay attention or don't really take notes or don't really like to pretend to have confidence, this sneakily can actually really mess you up. It can really kind of get you falling behind. So let's say that we have y equals 2x. Obviously that's very simple. The derivative would be very simple. Some different things you might see is, of course, you might see this listed as y prime. That means the derivative. You might also see this written as, here's the new one, dy dx. Have we ever seen that before? Okay. It is kind of a lot going on, but it literally means the same thing as y prime. Think about this. The derivative is the slope. The derivative is the gradient finder, right? That's what it does. And so what this is this is more of an accurate representation of gradient. dy is like the difference of y, so like the change in y. And then at the bottom, dx is like the change in x. So it's like the change in y over change of x. So it's like the rise over run. It just means slope. It just means gradient. If you see somebody say, find dy dx, it just means derivative. There's always a student or two who's like, oh my god, dy dx, and it's just a different way to write it down. Obviously, we have something like f of x equals 3x. I mean, whatever, it doesn't really matter. Another way that we could see this would be f prime of x and there's this like df dx. People don't really like that one. You don't really need to worry about that too much. If you see that dy dx, it just means derivative. And the last piece here is sometimes you'll see something like this. What this is it's not telling you this is the derivative or whatever. This is a whole question wrapped up into one. So sometimes you'll just see a question, it'll just say number 2, d over dx of 3x squared plus 1. Think about that. What we're missing here is a little y, or a little function. And then what we're followed with is a function. So they're kind of like, sorry, not how I expect that to work. They're kind of like doing one of these, where they're saying like, find a dy dx. Here is dy dx. Or here's y. So this just means the whole thing, take the derivative. So I'm not sure how much this is incorporated in the homework, but as we move forward, it'll just be like dy dx, and it's literally just like a panic alarm. Don't hit the panic alarm, just do the derivative and you'll be all right. Okay.